My name's Steve and I love people who make things. We're a nation of inventive, inspiring makers.
This room alone will produce 100,000 items a year. But yeah, it used to be full of cows.
And then I'd be, Afghanistan or Iraq, sat in my room just sketching out designs, waiting to come home to play around with them.
I'm on a mission to list the greatest products we make, because if we don't champion the skills on our doorstep, we risk losing them.
Running down to our left, we have hand cutting. The problem is getting labour now.
One of the biggest challenges we have here is our ageing workforce.
Join me as we hear stories from behind the factory doors.
I remember drawing my dad's house and he said, "Why don't you count the bricks?"
Oh, he wanted you to be quiet, didn't he? Do you ever have any sleepless nights, Alex?
I don't sleep.
Together, let's make more makers. Welcome to the factory next door and welcome to Surrey Research Park, where they're laying new white line road markings, which you can probably hear in the background. But we're not here for that. We're here to learn about a different industry, an industry that's worth £10 billion to the UK economy, the space industry. Oh, it looks like the road workers are just taking a pause, which is welcome relief. So we're surrounded by a collection of buildings, actually, all very modern looking. And within these buildings, they make space satellites. Whilst I go find the reception and introduce myself, have a listen to what's coming up in this week's show.
Lots of people don't understand that Surrey birthed the small satellite industry.
We as a country are at the cutting edge of space.
Did we just pass a bin in the shape of a rocket?
Yes. Get to talk to NASA. I mean, it's just really quite awesome.
It was the rise in consumer electronics that enabled Sir Martin Sweeting, who was our founder, and his colleagues at the university to build small satellites.
The story goes, Elon Musk came to Sir Martin and went, "How do I get into the space industry?" And
our financial director, it must be a nightmare for him because every month is different.
It's so quiet, isn't it? It's probably the quietest factory I've ever been to.
Lily Forward, Systems Engineer on the Lunar Pathfinder programme.
Andrew Greenhalgh, Head of Marketing.
Excellent, Lily, Andrew. So Andrew, you were just pointing out a giant dish on top of the building over there.
That is an antenna, a satellite antenna, which we use to receive and send signals to the satellite. So when the satellite's overhead, and it comes overhead every couple of hours or so, we can get a signal to it through that antenna and then to our spacecraft operations centre here in one of our buildings. We've launched 74 since we started back in 1981. That was our first launch, and we launched our 74th satellite 1 month ago. But at the moment, we're currently operating about 14 satellites.
Okay, where are we heading now, Lily?
We're heading over to the Kepler building, and this is our assembly, integration and test facility buildings where we do most of the flight assembly prep. We build the satellite into its box type shape. We do a lot of the testing there.
Is this your home? Is this where you spend most of your working time?
Not yet. So my project, we're still in the design phase, so we're still in our main building. But in the coming months, we'll be moving over into the Kepler building, and that's where we'll be starting to build up the spacecraft.
So it's always quite exciting when you go to the Kepler building, because that's when you know your project's about to start coming together.
Oh yeah, absolutely. It's seeing spacecraft hardware is really the exciting part. You spend most of the time on some computer design software or Excel. Seeing hardware in the assembly buildings is really exciting.
Did we just pass a bin in the shape of a rocket?
Yes. I mean, we're in a space design business. Everything has to be space related.
Of course. I was fascinated. Obviously, I did a bit of background reading on the industry, and I saw that UK government figures for last year, excluding satellite TV broadcasting, which I know they sweep up, but if you exclude that, the space industry income was 10 billion.
Yeah, it's pretty big. I mean, we turn over just under £100 million sterling here. In our 40-year history, we've done about 1.8 billion in turnover in total, most of that to export markets. But it's still a small industry. It's a small industry, but it's a niche industry, and it's a very, very high-profile industry.
The other fact I read, which you don't need to comment on, it's not really phrased as a question. This is just a fact that I thought was really interesting. So according to the UK government, every UK region is home to at least one headquarter of a space organisation.
Wow, I didn't know that. That's pretty cool. I mean, we've got a bigger space program in the country than we probably realise. Although the UK government don't operate many of their own satellites, they've just had one from us for their UK Space Command. We as a country are at the cutting edge of space. Again, most of that for international customers or for ESA, the European Space Agency, those sort of customers. But yeah, there's a long history of space manufacturing in this country.
Wow. Okay, a long grey corridor.
It doesn't seem too interesting at this point.
It doesn't. It feels like it could. It feels like we could be in a hospital. Oh, now here we go. You see, now you get to a big window, and actually you start to see some magicians at work.
These guys really are magicians. They're extremely highly skilled at what they do.
Okay, so we're looking in on a lab, microscopes. Everyone wearing, kind of blue suits and those attractive nets you have over your head and your beard, if you've got it.
Beard guards, absolutely. Fortunately, I shaved this morning, so I don't have to worry about the beard guard.
That's very fortunate. Tell me about what these colleagues are doing.
So this is our flight assembly line, where we build the PCA PCBs, and what they're doing at the moment is inspection of the boards. So
I'm going to have to stop you. What's a PCA PCB? That thing with lots of letters?
Printed circuit board and printed circuit assembly. So the assembly is once they had all the bits put onto it, and the board itself is the green bit with the tracks on that you see.
So I mean, the satellite needs to have onboard computer to control the satellite. So what we've got in here is circuit boards which contain lots of soldered joints and chips. And what these guys are doing, they're actually doing soldering. They're looking through the microscope to look at every joint on the circuit board and make sure that it's a true and good soldering joint. Some of it's done automatically, some of it's done by hand, because any one of our satellites has got tens of thousands of these soldering joints in the circuit boards. So it's fundamental that every board is perfect.
Miss one? What happens?
Maybe miss one, not a problem, because we usually have redundancy on our satellites, which means we have a dual string, which means there's not just one way of doing things. There's two ways of doing things, but you wouldn't want to get too many faults. No.
It's so interesting seeing colleagues kind of really studying them and working on them. I just had this assumption that it would just be all machine done. Obviously, it's not.
Yeah, no, it's a lot of hand layups. Obviously, all the design work is done by colleagues here, and yeah, you can automate a certain amount of it, but there are definitely some bits which still have to be done by a human in the loop.
What kind of backgrounds will these colleagues have?
So most of our colleagues are engineers or technicians. Many of them have got electrical engineering qualification, or mechanical engineering, or physics or maths. Lily, what's your qualification? Remind me.
Mechanical engineering.
Mechanical engineering. So what the guys do, these guys that we're looking at now who are working on the circuit boards, they're also take a second qualification, which is from the European Space Agency, where they are trained to be certified to do the type of work that they're doing. It's a special certification required for working on these types of things, especially if the mission in question is a mission for the European Space Agency, for example.
Stumbling through my early careers, went to the Tim Peake return mission, actually, which was what sparked me into the space industry. And I got to speak to Helen Sharman, who I'd heard of as a child growing up, first UK person into space. So I Googled Space Careers UK. And there happens to be a website called spacecareers.co.uk. So either I thought this is going to be a complete scam and I'm going to lose all my details, or as it was a real website. So I found it, Surrey Satellite's on there. I thought, this is great, I'll apply. Got here, and I have to say, I think they took a chance on me. Having no space engineering, no aerospace engineering, just pure mechanical, thermal and stress engineering is what we did at university. Anyway, they took a chance on me, and here I am, sort of 7 years later. I've been through the mechanical area, propulsion. I did a year on secondment representing SSTL at a defence company, and then now for the last 4 or 5 years, I've been on the Lunar Pathfinder programme.
It's so quiet, isn't it? It's probably the quietest factory I've ever been to.
Well, when you say factory, most people think of machines and oil and dirt, whereas machines, oil and dirt, we need to sort of keep out of a satellite, really. So when you say it's a factory, it is like you say, more of a hospitalised factory than your standard factory.
I see that I'm not allowed to just pop in and say hello to your colleagues and pat them on the back and offer them a digestive biscuit.
No, they won't be eating or drinking in the labs because we need to keep those very clean. So when Lily goes in the lab, she has to get dressed up. So it's full hair nets and clean room coats and shoe covers, usually gloves. Also, those guys in there had wrist straps on. Now that's about electric static discharge, isn't it?
ESD protection.
So ESD protection is to stop them being in any when they're working on a circuit board, any electricity, any static electricity from their body transmitting to the circuit board, which could be a problem. So.
Wow. And you wear wristbands to stop that happening?
Yeah, so what you'll have is a metal wrist strap, which will then be connected to the table you're sitting and working at. And that table itself will then be connected to the ground structure for the building. So any electricity, because everyone has an amount of resistance in their body, and as you're walking, you build up static electricity, which is why sometimes you'll get a zap off a door or even another person. So that having that grounding to the building just takes away any electrostatic discharge potential.
Blimey.
It's getting a bit noisy here, a bit more noise, but what we can mention perhaps here is...
Oh, a wall of historical photos. Lovely. And I love this photo of Martin from the early 1980s.
I can send you that through.
University of Surrey AMSAT scientific and educational spacecraft, and he sat in a very, very cool woolen jumper surrounded by computers.
Yeah.
It reminds me very much of, do you remember that early 1980s film called, was it War Games?
Yeah.
With Matthew Broderick?
Yeah,
it reminds me of that.
Those computers were chunky computers, just like those ones,
Yeah, they really were.
Yeah, now we're all working on laptops, which have got many more times the power, but these BBC type computers with huge monitors, I mean, that was the best of its day, Back when we started, back in the late 1970s and early 1980s in the University of Surrey, it was the rise in consumer electronics that enabled Sir Martin Sweeting, who was our founder, and his colleagues at the university to build small satellites, to use the electronics from computers and also the automotive industry and later on mobile phones technology, to take that technology and use it in space in a way it hadn't been used before. Up until that point, computers were built specially for space satellites, very expensive, very large computers. What we were doing here at Surrey was building small satellites using commercial off-the-shelf components.
You were just, shopping through a catalogue and saying, I'll take that part, and that part, please.
We took those chips, we took Intel chips that were used in normal computers, and we put them in space satellites in a way that was never done before.
You've arrived, you're obviously loving it. Why are you loving it?
Because space is cool. That's it, really, isn't it?
I have to pinch.
Interview ended. Space is cool. Every job has its ups and downs. It's hard work. There are problems you have to navigate, solutions you have to find. But then you have to pinch yourself and go, what I'm designing is going to space. It's launching from this Earth and orbiting us for the next 10 years. And in my case, it's not just orbiting the Earth, we're orbiting the moon. I mean, it's just unbelievably cool. And I keep saying cool, but you just have to pinch yourself. And sometimes I'll be on a conference call with our agency counterparts. There'll be European Space Agency there, there'll be NASA there, you're talking to UK space industry, and you have to go, I'm an early careers, mid-30s person talking to NASA. And you have to just pinch yourself every now and again going, this is phenomenal. What are my friends are all lawyers or whatever it might be. So I'm sure they have really interesting parts of their job as well, but I get to talk to NASA. I mean, it's just really quite awesome. Lots of people don't understand that Surrey birthed the small satellite industry. I think our satellites is your big agencies, like I mentioned, UK Space Agency, ESA, NASA. America do all the satellites. No, we were the forefront of small satellites.
Some people
Tell me
call
about
us
that, Andrew.
Yeah, some people call us the pioneers of the small sat revolution. Somebody called us the original new space renegade. The fact that we're still at the forefront of small sat technology to this day, the fact that we still employ over 300 satellite engineers, the fact that many of our ex-colleagues have gone on, left SSTL and gone on to form their own companies in the space industry. It's just such a great story.
It's one of the stories I love. I don't know if it's fiction or not, is that 10 years, maybe 2 decades ago, Elon Musk was on the
He was a
he's
minority,
on the board.
He was a minority shareholder
of SSTL. And he came and spoke to Sir Martin Sweeting and said, and this is the bit I don't know how fictional it is, but there's the story goes, Elon Musk came to Sir Martin and went, how do I get into the space industry? And Sir Martin went, well, you need to look at cheaper ways of launching. And then you look sort of 5 years, 10 years later, and here's SpaceX doing, and you're going, oh, I wonder which little bit of whether or not SSTL had a very small impact in developing this absolutely huge launch agency. And it's always quite nice to see how, again, a small little company in the green Surrey Hills has helped maybe plant the seed in SpaceX's history.
Hi, if you're enjoying the show and want to support our makers and manufacturers, please hit the subscribe or follow button. If you're listening on Apple, hit the stars and rate the show. It takes a small moment but makes a big difference. Thanks. Right, back to the chat. Okay, well, another corridor, more labs.
Yeah. Where's the actual?
Oh, look, there we go, big sign. No smoking, no drinking, no eating.
Yeah. So those are the labs, the meeting rooms.
Yeah, so
What are we looking at here?
This large wheel here, so that's our 200 size wheel.
And when we talk about wheels here, it's not
car wheel.
It's not like a car wheel.
So instead, think of it as an inertial disc, so a mass disc, with bearings around the outside, spinning around inside of a cover. So you have a wheel inside, built inside of the main housing, for example. This wheel down here has just completed its 1 billion. 1 billionth revolution, and that's partly to de-risk the Lunar Pathfinder satellite, where we'll be using these large wheels, 4 of these large wheels on our satellite.
What do you use the wheels for on your satellites?
We tend to use them on each axis of the spacecraft to steer the spacecraft in some respects. Imagining the sort of GCSE experiment you can do in physics, where you sit someone on a spinny chair, you set a bike tyre off in motion, they hold it, and if they tilt it sideways, they'll rotate the chair around. So using that sort of torque to move the spacecraft, and we'll put them on each axis with usually 1 spare in the most critical axis in case we have a failure.
Sounds quite complicated.
It is, isn't it? There's 2 elements to a satellite. There's a platform and a payload. The payload is the thing that's being carried into space that's going to do something when it's in there. The platform is what carries the payload into space. And what makes up the platform is things like onboard computers, the reaction wheels, that steer the satellite or point the satellite, the propulsion system, the antennas so you can send signals backwards and forwards to the satellite, all the things that the batteries, all the things that will keep that satellite up in space for the 5 years, 7 years, however many years of orbital life that we need it for. When we first started, we were building 1 satellite at a time, and now we've got 9 in manufacture. And they're satellites, the low Earth orbit Earth observation satellites, and then we've got Lily's Lunar Pathfinder satellite that's going to go to the moon or go around the moon. So the key, I think, is to have a wide range of different types of capability. We always operate in the microsatellite, so 100 to 300 kilos. That's our sort of area of competence, if you like. But make sure that we're building satellites for anybody in that market that wants a satellite of that size. And it is cutthroat, and it's ruthless, and it's competitive, and it's challenging. But maybe that's the most exciting thing about it.
And I imagine this is actually a really growing market.
It's a growing market, but there's a lot of noise in it as well. So what you find is a lot of startups. So startup companies who will make noises about what they can do, but then they've got no track record. So we're competing against people who literally can say they can do something, but have never actually done it. But it's a feast or famine type market in that our financial director, it must be a nightmare for him because every month is different. We're not building, every year we're just like building widgets and we do 10 more this year. it's 1 month to the next. It's a project-driven business, so we build a satellite for 2.5 years, and then that's it. It's launched, and then we've got to start a new one. It is really lumpy as a business, really challenging.
How then do you manage actually workforce if it's such a lumpy?
That's one of the hardest things, because some elements of our workforce are specialists in certain areas, and they're not fully maximised at any given time. But you can't lay people off, because then you might not be able to hire them again. So we need to keep a steady workforce. So we've got the skill set in the company, but how do you organise their workflows when the work is as lumpy as it is? So it's a real challenge. So managing the company in terms of the resources is one of the most challenging things. These rooms are the bridges. We call these bridges. So basically, these rooms, and if you can just see through that window, you can see.
They look a bit like TV studios.
Kind of.
On there, looks like a radio studio.
Yeah. So our engineers, the engineers are in these rooms. So each one of these bridges, we call them, are for a particular mission. And so basically the engineers can be in one of these bridges hooked up to the satellite that's being tested in the main facility, which means they don't have to go in the main AIT facility. We can keep the air clean. But up here, we can have separate project teams that are working away in their own little offices. What else can we show you up here? This is our optical centre of competence, or basically our optical clean room, where we build our cameras. And just over there in the main clean room is this sub-clean room, if you like, which is the air in there is cleaned to a higher degree, so that because it's very critical that when we're putting the camera together with the mirrors and the detectors, that there is no dust, there's no hair, there's no foreign particles. Ultra important that we keep that camera 100% clean.
So you've got a clean room within a clean room.
So a normal clean room is what's called an ISO 8 grade of a clean room, and I believe the Optical Centre of Excellence is an ISO 9 or an ISO... No, sorry, it goes lower, doesn't it? It's an ISO 5. So the closer to 1 you get, the cleaner the room is. But yes, we go through a clean room to get into the clean room.
And is that just filters cleaning the air?
Filters, temperature sensors, relative humidity sensors, it's all controlled.
Yeah, we're cleaning the air. We're also making sure the humidity is right, so that it's perfect for building satellites.
We've got other things as well. So the door, to get into the clean room, there's always positive pressure within the room. So imagine if you had no positive pressure, you'd open the door and any dust from outside would be able to ingress into the room. So a positive pressure means as soon as you open the door, any potential dust or particulates is pushed out.
Like all the leaves that keep coming into my house when I walk out the door in the morning.
What you need is a positive pressure within the house, so it pushes them out of the way.
Okay, I'll have a look into that.
So spacecraft engineers who are sort of mid-career, who've got 5 to 10 years experience like Lily has, they're rare. They are rare and they're a commodity, and they can work where. Lily's smiling now because she knows that she's a valuable commodity. So people get poached, they're attractive. And what we tend to do is, I say, Lily came in on our graduate program 7 or 8 years ago, and then after 7 or 8 years of experience, she's worked on 2 or 3 missions now. She can go anywhere she wants. So keeping people here is one of the key things that we have to do, and one of the ways we do it at Surrey Satellite is, and the way we've been successful is by having such a wide range of missions that people can work on.
You're not leaving, are you, Lily?
Oh, absolutely not. Where else am I going to work on a lunar program? It's just incredible. As I said, it sounds silly, but the coolness factor of working in the space industry, and I don't know what the HR department do, but there is a criteria in their selection process, which means everyone has the same amount of, all the engineers are the same amount of odd.
This would be a good place, Lily, for you to talk about the lunar mission, the Lunar Pathfinder.
This is your mission. This is your mission. A big poster on the corridor wall here.
Yeah, I wouldn't say just my mission, and we've got a huge team working on it. Most of the company has been working on this platform over the last 4 or 5 years. So overall, Lunar Pathfinder is the UK's first satellite to orbit the moon. Very exciting. And it's going to be a communications relay satellite for assets landing on the lunar surface or orbiting around the moon. So if you could do direct to Earth communications, but to do that you have to have a big battery with a big antenna with lots of high power units, whereas if you can just speak to a local sorry, you can't see quotation marks on the on a podcast, can you? If you can speak to a local communications relay, such as Lunar Pathfinder, you don't need to have such high power batteries, antennas, RF equipment, and therefore you are lighter and cheaper to launch, because getting to the moon is expensive.
I was interested in one of the phrases you said there, assets landing on the moon.
Assets landing on the moon. We've had, in the last, I won't say 2 years, we've had multiple assets landing on the moon, looking at the commercial lunar payload services from NASA. You've had, I think, JAXA, so Japanese Space Agency, ISRO, Indian Space Agency, Chinese Space Agency as well, I believe, have all had assets land on the moon.
Assets meaning landers and rovers.
Yeah.
So things that are going to the moon. So there are hundreds of missions planned for the moon over the next 20, 30, 40 years. And some of those missions are going to be on the far side of the moon, which means there's not a direct communication link to Earth. So that's why you need an orbiting satellite, which will pick up those communication signals from the far side and transmit it back to the ground station here, so the mission controllers can understand what's going on.
What happens when you've finished your satellite? You know, you've got it there, it's like it's come through its vibration test, it's all done, presumably you box it up.
Yeah, we box it and send it to the launch site. So about 6 weeks before the launch, we send it to the launch site. We got a team of guys who attach it to the rocket, and then it gets launched along with a load of other satellites as well. There were 76 satellites on the last launch. Ours was just one of them. And it goes into low Earth orbit from there.
And I guess because they're not so big, you know, I mean, it just goes in a regular sized lorry. It's not like you would notice it passing you on the motorway, would you?
Not quite. So we'll put it in sort of a big sort of articulated lorry. It goes in the back of one of those. It's had most of the transfer cases that we have will be controlled on the inside for humidity. And then it will tend to get flown out. You'll put it onto a standard air freight. So we have to make sure the boxes are the right size to air freight them out.
I know, I only ask because it's so amazing and kind of like, wow, sci-fi. It's almost slightly mundane that it just gets loaded on the back of a lorry and is shipped out of the science park.
Like a piece of normal freight. Yeah, it is a bit. That's the most agricultural part of it, is when it goes on an articulated lorry to the launch site. Everything else is pretty high tech.
One of the things I really want to ask before I leave is just about launch day. I imagine that must be the most extraordinary rush.
For everyone else, it's a rush. For the engineer the systems engineer who's sort of spearheaded that program, one of my good friends was the lead systems engineer on our MOD satellite that just launched. And the launch day itself for them is nail-biting, absolutely nail-biting, because for a LEO satellite, you do the launch, sort of 45 minutes later.
Sorry, what's a LEO?
A low Earth orbit.
Oh, sorry.
So that's the sort of 500 kilometre zone that we usually launch into. So you ship the spacecraft off, it gets integrated onto the launch vehicle. Nominally at the moment, we're using sort of SpaceX rideshare because, you know, a lot of customers are using them. Launch happens, T-minus 10 down to 0, get the launch, and 45 minutes later, you're tipped off the satellite. You're then in a race against time to get contact with that satellite, make sure it's turned on. Is it where you expect it's going to be? Did you get tipped off the launch vehicle 10 minutes earlier, 10 minutes later than expected? So you have to find it, turn it on. You've got people watching. You have press looking through the windows going, what's going on? Can we see telemetry? So for them, it's extraordinarily stressful. For the rest of the company, for us, but they're going, this is great. Look, it's a launch. Yeah. We've watched it. It's fine.
The latest satellite we launched was called Tyche. It's an Earth observation satellite for UK Space Command, so the military wing, if you like, that operates satellites, and it's their first Earth observation satellite. So it's hugely important for them, because the success of this satellite will unlock the budget for future satellite programs. And as Lily says, there are three key elements to the launch. First of all, the rocket leaving the launch pad. It goes up, it doesn't explode on the launch pad, it goes into orbit, fantastic. Then Tyche, which is the name of the satellite, was deployed from the rocket 1 hour and 18 minutes into the flight. And the mission controller will say the words, Tyche, deploy confirmed. That's the second time that you're relieved, because it's not stuck to the rocket. And then the third time, which is the key one, is when an hour and a half later, that satellite will pass over our ground station and we receive a signal from the satellite. When that's happened, then you know it's been a successful launch.
What do you do then?
Then you breathe. Then you breathe.
I am very confident that both of you got amazing moments still ahead of you, particularly with the Lunar Pathfinder. Very best of luck with that, and thank you so much for taking the time to show me around this extraordinary factory.
You're welcome.
You're welcome. Thank you for coming.
Okay, number 22 on our list of the greatest products we make here, the Space Satellite. It doesn't feel right to put it in the shed though. I think we'll just leave it to orbiters from above. My thanks to Lily and Andrew for showing us around, and as always, thanks to you for letting me hang out with you for the past half an hour. For those of you who haven't heard, great news, we won an award last week, the Best Business Show at the Independent Podcast Awards. So congratulations to you. I've always said, if you listen to the show, you're part of the factory next door. Okay, right. I'm off to watch some Star Wars maybe, or should it be Star Trek? I think I'll need to ask the team at Surrey Satellite Technologies which they prefer. I'm going to do that now. Wherever you are, whatever you're doing, I hope you're happy. Until next time, bye.